Welcome to the AWS Nordics webinar series. This series consists of 4 webinars, all 4 focusing on how to use data insights to drive organizations' innovation and empower citizens. My name is Nilüfer Viljanen. I'm heading up AWS Nordics marketing for public sector. Today, we talk about the value of data with machine learning and artificial intelligence. And I have with me Neil McKinn, Technical Business Development Manager, AWS, Michael Jensen, Head of Technology and Innovation at TV2 Fin, Denmark, and Steinar Søreide, Chief Technology Officer, Mjøl. Before we start, some housekeeping. You will receive the content of the webinar shortly after this webinar, and the webinar will also be available on demand later on. And please feel free to post your questions on the chat window, and we will do our best to respond to them. However, if we don't get to respond to all of your questions, we will make sure that you get responses via email. And with that said, I hand over to Neil.
Thank you very much, Nilüfer. This is an incredibly exciting time around artificial intelligence and machine learning. It's absolutely being used in more and more and more domains all the time. I mean, looking across this chart, picking out things like contact centers and how customer service can be improved with artificial intelligence, machine learning, transcribing the calls as they're happening, understanding the trends and why people are ringing. Understanding things like translation to actually enable people to understand languages they never understood before, and to do so in a real-time way that actually really helps things. It's interesting as we see organizations in many different areas moving into using AI and machine learning. They're doing so in various different ways, and this is kind of a maturity model, looking through from some organizations who are really at the beginning of their journey, just starting to think about what it could do for them, but without much capability themselves, through to those who are experimenting, trying out a few things, perhaps in an uncoordinated way in different departments, different divisions, trying things out. And then stepping up towards the third level of productionizing. Organizations here are starting to grapple with how do we actually take inference, put models into production, how do we manage those, how do we maintain those, how do we build those, and how do we create that data pipeline, and also create the value chain of using these kind of technologies to really make a difference, maybe financially, or make a difference in the service, in the effectiveness of their operations. And finally, there are some organizations who are really leading in this space. And to be candid, I think there's actually relatively few who are really leading in the space, for whom they have a machine learning first strategy, for whom they see data as an asset that they curate, for whom they have leadership oversight and governance. They've invested in the tooling, they've invested in skilling at their organization, and right the way through everything they do, they're considering how could AI and machine learning make a difference to what we do. Thinking through how that may come about, there's really 3 pillars to build this competency and to move to maturity. There's absolutely the resourcing side. How do you train, organize your resources, your staff right across your organization to have the expertise, the technical expertise of working with data, the data science expertise of producing results with data, through to the understanding of how to drive value from the use of these technologies as well. There's the operations pillar of how do we actually identify what to do with it, to recognize the value we can bring with it, and to think about how you may have to transform an organization to actually shift and drive new value in these ways. And then finally, the underlying pillar of technology, the tools, the infrastructure, the equipment, the algorithms that will actually help derive this. At AWS, we provide lots of capability in all of these pillars. We can support people as they move towards maturity in each of these. And I was going to look mostly at the technology pillar in what I share next. So our mission at AWS is very much to make machine learning something that you can exploit, make AI and machine learning available, and to do so by putting it into the hands of every developer, as well as enabling data scientists and machine learning practitioners to be more effective and to be more productive. We recognize The opportunity is so great in this space for all sorts of organizations. Not all of them are going to be able to invest in creating their own machine learning team, their own expertise in this space. Some of them will want to just have developers accessing tools where other people have pre-built models and algorithms that they can then deploy. And so we're making it easier right across the stack to achieve that. But machine learning is active in many, many different fields and many domains. This is an interesting example. I don't know whether it's the recent coronavirus that makes me think of this, but toilet rolls, certainly in the country I live in, there was a huge issue with people stockpiling toilet rolls and a shortage at the beginning of this coronavirus time. Georgia Pacific are a manufacturer who are in the business of making toilet rolls. And they've used machine learning to improve their production lines by identifying the faults and likelihood of tears occurring that stop a roll being formed from the very large bales of paper rolls rolling down into the small toilet rolls that you and I are more familiar with. So it's really every field that's relevant. So the field of manufacturing, the field of health, where the likes of Cerner are using machine learning to improve their patient relationships, to look at the data within the patient records, to help identify and diagnose things more quickly. And they recognize that there are certain conditions that they can actually identify months before they're clinically manifesting by tracking the vital signs and using machine learning on those. And I think very much in every field of life, machine learning can make a difference. In Norway, they are tracking the vital signs of cattle and milk production, looking at the lives of their cows, understanding their weight, their growth, their other biodata, and identifying how to actually support them to be have greater lives and produce better quality and quantity of milk. Very much every field of life can be looked at through the lens of machine learning with the opportunity to make it better. This is the technology stack that AWS offer. It's the broadest, the most complete set of AI and machine learning capabilities available today. At the foundation is the machine learning frameworks and infrastructure. So here we have the kind of fundamentals, the compute instances, the abilities to access compute power of varying kinds to the most powerful GPUs, the P3DN GPUs instances, which are the most powerful in the cloud, right down to the other end, the inferentia chip driving the lowest cost of inference for machine learning models in the cloud at the moment. We've also invested in capabilities to reduce the cost. So things like our elastic inference capability, letting you blend different compute types to optimize what an algorithm needs in order to reduce the cost. We've put lots of energy and effort into taking the frameworks that are being produced by the likes of Google and Facebook and making them available and working really hard to make them run incredibly effectively on our infrastructure. It's interesting to actually see some of the benchmarks for driving performance out of TensorFlow. People get higher performance running it on the AWS cloud, and maybe that's why we're seeing 85% of all the TensorFlow implementations in the cloud are actually running on the AWS stack. What we've done is to make it really easy for research data scientists to use this framework by packaging up deep learning Amazon Machine Images or containers so that you could quickly load up a compute instance of the type that you need with all of those libraries, all of those frameworks pre-built and integrated together in a way that works, greatly reducing the time it takes to start your project. What we are seeing though is a lot of research scientists who have been writing bespoke machine learning models and algorithms down at this lowest level are starting to actually move up into the SageMaker level, the machine learning services level, where we're providing more support around the machine learning practitioner to make it quicker and easier. So we're taking away fundamentally some of the challenges of managing the compute infrastructure, managing the storage, switching between different types, getting different algorithms to be available to be used, and providing additional support around the whole life cycle. So that life cycle of machine learning, anybody who's worked in this space will know that it's complex, it's iterative, there's kind of to and fro and back and forth. There's the collection of the data, the preparation of the data, the building out of the features, the choosing of the right algorithm, trying different algorithms to work, the training and tuning, managing the compute environment for the training, multiple training runs. And then finally, when something really works, that deployment and managing that model into production. It's quite an arduous, time-consuming and challenging process. With Amazon SageMaker, we have sought to bring additional capability and facilities right across that pipeline, right across that time to help in all these different ways. And I wanted to pick on some of these, but maybe it's just worth thinking of a parallel here. We have brought debuggers, we have brought optimization algorithms, we have brought collaborative notebooks, we have brought automation for the deployment, automation for the tracking and monitoring of models in production to see if they're drifting. All of this is maybe akin to what happened 20 years ago with software development environments, where the integrated development environment became a thing, where optimizers and debuggers and source code control all came together. And we are looking to do the same now for machine learning to make it quicker and easier. So stepping through a few of these things, Amazon SageMaker is that integrated design environment. It lets you collaborate, it lets you share models, lets you build higher quality models and to be more productive. We're seeing teams who are adopting SageMaker find a tenfold improvement in their productivity and model building. Overall, we're finding a reduction in the total cost of ownership over a three-year period for teams using SageMaker of around 54%. But Studio is that single pane, it's that familiar Jupyter Labs notebook with Python code or R code, but it brings it all together, integrates it with source code control. The notebooks are perhaps at the heart of that, allowing you to share and collaborate. And within that, you could access them through single sign-on, so each of your team can be set up to just click on a link and go straight into this environment. It's managed and secure. It lets you collaborate easily. If you've ever tried, as a machine learning practitioner, working on a project to share your script with somebody else and get them to run it, you'll find there's all sorts of headaches of managing the environments and managing the libraries you're using and managing the frameworks. We've solved that. So it's easy to package up the work you're doing and share it with one another, and we worry about all that back-end integration and gubbins for you. We built into SageMaker a whole range of algorithms which are quick and easy to call, quick and easy to use, so you could prepare the data set the parameters up for one of these algorithms, and it'd be there. It's also extensible. You could bring your own algorithms as well. You could package up algorithms you're using in TensorFlow or MXNet in script mode and run those within SageMaker. We've invested in making it quicker and easier to train. So the training and the optimization of things like hyperparameter optimization, where you could specify, please search over this range of parameters for this model and find the best set for me. We've also invested in debugging. So it's now possible to look within the training runs and actually see what's happening by inspecting the tensors at different epochs within the whole training run and setting up configurable rules. We provide a set of rules off the shelf as it was, but you could extend those and have ways of identifying things when they're going wrong within the training set itself to build it, to make it quicker, to make it more productive. And in terms of deployment, we've often been able to build models, but getting them into production is hard. We've made it easier with SageMaker that you can take models that you built in SageMaker, or in fact models you built elsewhere, and package them for deployment within the cloud using containers within SageMaker, and then wrapping them perhaps behind an elastic load balancer that scale up and scale down according to the demand on that particular inference type. We've gone further, though, in the recent release with the ability to actually monitor the models as they're being used. There's a real problem with machine learning, and maybe this year, 2020, with the coronavirus, has been a really interesting point where all the data's changed, all our lives have changed, the way we do everything changes. It's hardly an aspect of life which hasn't been disrupted in the data stream by this year. How do you know when that's happened for your models in production, maybe in far less obvious ways than this year? One way is to compare the characteristics of the data that you used for training with the characteristics of the data that you're seeing now in the inference workload. We've automated that step with Model Monitor. You can run a sophisticated analysis of the training data, and then in everyday use of that inference in production, track and highlight when concepts are drifting, when the data's moving, and let you know when perhaps it's time to rebuild that model because fundamentally your data's moved. All of this makes it quicker and easier for machine learning practitioners to work. But we've gone one step further still and created an autopilot capability that will not only search for the best optimized parameters for a given algorithm, but will search for the best algorithm to use as well. And not only that, it will automatically build additional features to the data. So you can specify a data set. We will use a library that we've already got of pre-built feature extensions to identify additional ways to get more value out of that data. And then we will identify all the possible algorithms and run them all and search for them. So it's kind of like an automated ML process for you. And this works for a number of different problem types like regression and single class and multi-class classification problems. It's interesting that it's distinctive from the other AutoML capabilities on the market because it's completely open. At the end of the process, you will see all the different scripts it's built and the output it's achieved, and you can then take them and refine them. In fact, I often say to the heads of teams of practitioners, why don't you, on the first day when somebody starts a new project, just get them to spend the morning running autopilot, and then the rest of the week they're working on that project, see if they can beat what it's produced. There is a reality, though, with AI that it's not perfect. There will be times when actually an AI algorithm struggles to understand an image, understand the data, produce a prediction, and it will have a low confidence of the predictions that it's giving. In that case, what we need to do is to bring human expertise to bear as well. We've created a service that builds that ability to have a human workforce, reviews those predictions for just those cases where it's appropriate. And we can hook these services together with some of our AI services and with SageMaker. And you can flow the results into a team that you're using. One such application of this is actually with the health service in the UK. With the health service in the UK, they've recognized this capability as a game changer. With them, we're actually looking at reading prescriptions written by doctors, dentists, giving medication to patients. And in the cases like this, looking at the image on the left-hand side, pulling out things like what was the name of the doctor, what was the age of the patient, what are the actual medications that have been prescribed and in what volumes. Benefits for them is that they will greatly reduce the human effort and the cost per transaction as they're doing this. And across the whole of the UK, they're doing millions of prescriptions every month. But some of them are not as pretty as the one I just showed you. Some of them are more classically like a doctor's handwriting. So looking at this very top line, mirtazapine, is it 15 or is it 45 milligrams? It's not very easy to believe an AI model would get that right. In the case of the one that we actually built with SageMaker to do this, it did suggest the answer was 45, whereas I look at it and think maybe it's 15. But what you really need is a human to review that. So that's exactly what they've built, the capability to take the output from Textrat models or SageMaker models and flow it into a human review process so that different humans could then review it, correct it. It's also fascinating, not only do you then have huge confidence that you can productionize with this, you're also implicitly building the best training set ever as you're identifying the very parts where the model's actually got it wrong and you'd really love to pass it back and correct that and get an updated training set to rebuild the models next time round. Some other examples of what people are doing with SageMaker. Rovio are a games design studio in Finland, and they're behind the Angry Birds Dream Blast. If you've played it, you'll know there are very, very many levels and they release multiple levels on a very frequent basis. They're actually using SageMaker to help optimize and create those levels more quickly, matching between the player experience and the difficulty of progressing the level, whilst also bringing creativity and automatically building in a really fast way all those levels. Other use cases like Beth Israel Deaconess Medical Center is a really big hospital, and they are using SageMaker to analyze all the paperwork for a patient to check that they've given consent. They actually found they had to cancel a number of surgical procedures really very shortly before going into the operating theatre, sometimes even just moments before, because they couldn't have evidence they'd got the paperwork all in track. So now they're using SageMaker to actually analyze all the paperwork and verify that if the consent is given, it's increased the utilization of the most precious resource they have, their operating theatres and all the professional staff in there. In a different field, the Bundesliga, the German Football League, are looking at the footage of the football games using SageMaker to track what's happening kick by kick, ball by ball within the whole of the game, and putting on better promotional results, marketing promotions to their viewers, and actually enriching and improving the experience of viewers watching the game. And all of that's possible with this middle layer of SageMaker. But at the top of the stack, we've also invested very heavily in creating AI services where we've done the modeling already. We've built the models and they're there for you to use. Right across the field, so looking at this, we've got things like forecast at the top towards the right-hand side, where we can take a time series and predict what will happen next, based out of our huge expertise and experience within Amazon across the retail estate. Interesting now to see the likes of utility providers providing gas and electric, but taking the time series data from millions of customers to identify and predict what they're likely to do day by day going forward, aggregating those up to provide huge cost efficiencies in their operation. Kendra Search allows you to take large bodies of words and structured documents, text, PDFs, and build a natural language enterprise search across the whole of that. Translates between languages, transcribe, takes audio and produces the spoken written word out of it so that you can see it. In combination with things like Comprehend to actually search through the natural language processing to identify the entities which are being talked about within a given document. With some examples, FINRA are actually ingesting millions of documents to do with companies producing their reports, to do with trades that are going on in the stock market, to identify where things may be fraudulent. So they've got a team of human investigators, but they're doing an exhaustive search through this archive of material to identify the most pertinent and relevant pieces first, and then build models to identify what's most useful to invest the energy of the human investigators to actually look at. And that's kind of an interesting theme of how can you take data, how can you look across huge volumes of data, huge archives, and actually hone in on the most relevant and useful bit to look at. Stepping up into the recognition space and looking at images and videos, Rekognition is our product that has pre-built models that allow you to analyze what's within an image or what's within a video. So here you see a picture of a cyclist riding on the mountaintops, and we can identify that as a mountain bike, it's going over a rock, it's got a person cycling it, coming over the crest, and it's an outdoor shot. And these percentages indicate our confidence of each of those. That's just one use case. There's very many within Rekognition. We've got the capability to identify faces and match faces between different images, and match faces against a list of perhaps celebrities that we've got, or indeed your own list of faces that are known to you. So you can use it for things like verification of identity. We can automatically label things, so looking at images, identifying what you can see within there, reading text within images, tracking the paths that say footballers at the Bundesliga are following on the football field, and tracking who they are and track them in real time, recognizing what's going on. Moderation is an interesting area. Oftentimes, particularly with user-generated content, there is a need to review. Is it salacious? Is it fit for purpose? Could we actually publish this? Rather than having teams of humans watch everything, why not screen it to identify automatically, is there nudity? Is there violence? We can do that with Rekognition. We can also use it to help analyze personal interaction, so tracking at a much more individual level, the customer analysis. So looking and trending by what kind of activities people are doing, what age brands there are, what sort of usage they're doing for different things. Lots of interesting use cases there. And I wanted to give a particular use case of Ayla Credit, who are using recognition in Northern Africa. And they've got a problem. They're a credit lending agency. They loan money on short term to people, particularly around really urgent things. So perhaps a father wants to get a little loan in order to enable him to take his daughter to get medical advice at the hospital. Well, that's not something that can wait. That's not something that really could suffer having a 2 or 3 week delay whilst you verify your identity in your account. So they've turned to using image recognition and they looked at the market and recognized that the one that worked best for their particular user community in North Africa was Amazon Recognition. And they're using that in conjunction with other sources as part of the identity verification, meaning that they can offer those loans in a much quicker and more direct way. So I wanted to pass on now to Michael to share more about the use of AI services in the data archives that they have within TV2 Fin.
Thank you, Neil. Just before we go on with you, Michael, we have received several questions on the chat. I will just try to pick a few, Neil, if you could respond to them, and then for the rest, we will get back on mail to the attendees who had
Yes, of course.
questions. Yeah, sure. So let me see. Here's one question. I think you have been very passionate about what you have just walked us through. So here's one question: what use cases for ML excite you most?
Oh, wow. Well, I think one that comes to mind is a company called Axial 3D in Northern Ireland, who they take the imagery that you use in hospitals. So imagine I had an accident and I fractured my bones in a really complicated way and needed to have surgery. So they'd probably send me for an MRI scan, and they take all that imagery. And then what they do is really fascinating. They use machine learning models to analyze the imagery in order to accurately reconstruct what the bone looks like within the body. And then they put it to a 3D printer. So they print out a full 3D image, 3D object equivalent to what there is within the body, so that the surgeon and the rest of the surgeon's team can actually plan the operation. They can, hold the actual objects they're going to be fixing in their hands and manipulate them and plan the way they want to do it before they actually have to go into the theatre. And in doing this, they found ways of massively reducing the time in surgery and massively increasing the confidence and expertise within what they're doing. It's just a really nice way of making it physical and making it real. Another use case, which is maybe slightly less exciting, but I'm seeing a lot of interest in, is document automation. And whilst over recent years we've made huge strides towards digitization and filling things in on web forms, I think the reality is that documents and forms and paper, it's always going to be with us. And a lot of companies are now taking that paperwork, that white mail, and scanning it, and then automating the process into a machine readable format. So not just an image of it, but actually reading the words and understanding how the form was filled in, and then automating the processes. So maybe it's not quite so life-changing as Axial 3D's work to help doctors, but I think it's a great way of reducing some of the mundane jobs where people used to just transcribe from a form into a data entry job.
Sounds both very interesting, actually. Um, just a quick answer, maybe, on the next question. What are the biggest success factors for an organization wanting to success in ML, in machine learning?
Oh, quick answer. I could talk for a day on that. Really, I'd probably just call out three themes. There's investing in training and equipping their staff with the right skills. And that's skills with the technologies as well as skills with the benefit realization and the financial modeling and the recognizing the vision. There's very much a top-down leadership as a second thing. Organizations where the leadership recognize the value this can bring and are prepared to lead and to govern well and to oversee that, as well as then Yeah, and I guess I would say this having given the talk, but investment in the right tooling to enable those people who you've trained to be as effective and productive as possible.
Great. Thank you, Neil. With that, we will hand over to Michael. Michael, the stage is yours. Thank you.
My name is Michael Jensen. I'm Head of Technology and Innovation for TV2 Fyn in Denmark. You can have my email as well, so if any questions afterwards or think of anything, just give me an email and of course I will answer you back. TV2 Fyn in Denmark is one of the public funded broadcasters in Denmark on a regional basis. So we are 8 independent regions in Denmark, so we have all our saying we are owned by the Ministry of Culture, the Danish state, but we are 100% independent, so we can do whatever we want. So we are probably, I think we are the first region that will go into this world now, working with AI, working with cloud, but I think all the others will come afterwards. We are around 100 employees at this media house and this TV station. And we broadcast on the main TV2 Denmark's channel. We have our own channel. Of course, we use social media, and we have our own web page. So this is basically what we are doing now. For the project we are working right now, we are talking about, I think it's a new word, or it came up a year ago or something like that, called story-centric workflow. And it means really that the story is in the center. And whatever you do from this center, you publish out to different platforms. You can say, I always have my story, and within this story, I have published to TV, linear TV, to web, to social media, and whatever. So the story will always be connected in one bucket. The main thing for us to do this was to break down the silos. In a media house like ours, we could see we have different departments. We have people working with linear television, social media, with our CMS and web page, and people were not talking together. You know, they were working just, okay, this is my little world, and I don't talk to all the other guys. So it was very important for us that we could use a service where everybody could share the same material at the same time, share the same ideas, share the same stories. So the main thing for us was to break down the silos. And another thing, when you start to work with this, you got a lot of things that can help you, a lot of enablers. So we want to use artificial intelligence. And we don't just want to use artificial intelligence to make it easier for the journalists to take all the boring boring jobs away. No, we really want to use artificial to make it easier and to do what machines do better than human beings. And we can see that because we are already started to work with face recognition, with transcriptions, object recognition, and the machine will do it 100% for us, much easier and much faster than a human being can do it. And that comes to our archive, because as today, when you're searching in the old archive, yes, you should be very specific and you get very few hits for what you're searching for. But with the help of artificial intelligence, they will find all the objects, they will find all the spoken words, find all the human, the faces that you are looking for. So we will have a much better archive. And when you search in the old archive, you have to restore it to work with it. Here you will have access to all the material instantly when you have found it. And again, it's a bit in the same way as breaking down the silos. We want a better way to collaborate. We want to share our material. We want to share our stories among the staff in the house. And of course, we need to publish on multiple platforms. Another thing we have been working with in this project is that we should be publishing during acquisition, meaning we should be publishing almost while the cameramen are shooting in the field. And if we look at this screen here, we can see that the cameraman is out in the field shooting. His material will go to the cloud in a proxy file. It will be analyzed by Mimir, and instantly after that, they can start to work with it in the newsroom, meaning that we can put our stories on the web page or on social media while we are shooting. Back home at our facility, we will start an ingest procedure in a 100 MXF file, meaning a 1080p file. This is a very high-res, a big file, but these files will be stored on local storage. So for us, it's a more like a hybrid solution, and these files will be linked to the proxy files. So even though the journalists have started to work from the cloud material, these files will be linked in high res, so you can use them for television as well. We are quite a small house, 100 employees. We don't have a lot of staff for support. We don't have a lot of coders and people could work with that. But in this project, it has been very, very helpful to work with Amazon because they have sent all the specialists to us to talk us through and what is best practice. So even though we at the beginning had, just a little knowledge about things like that, we had a lot of help to get through. So even though you are small, it's not a problem because the help is out there. So I would like to give a word to Steinar Søreide, because he's really going to get you through to what is Mimir doing for TV2 Fyn. Thank you.
Thank you, Michael. And just before we pass on to Steinar, here are a few questions on the chat, and let me pick one here is, how do you see cloud technology further help broadcast organizations to grow?
Definitely it will grow because, talking about cloud, you have no problem in scaling. The amount that we are storing right now will be different in 2 or 3 years or even in 1 month. So the question about scaling will never be a problem. And if you talk about artificial intelligence and machine learning, I think we are just scratching the surface right now. There will be so many things that will be very, very helpful for the broadcasters.
Thank you. And just if we have 1 more minute, and here's another question among others is, actually, how will AI/ML be enablers for broadcasters?
Yeah, again, someone will always say yes. For IA, you can take all the boring things away from your job, but I think that's only one part of it, because that would also do, but it will help you get better. You will help you produce faster. And meaning when we have a story that breaks, we need to get out as fast as possible, because the competition is huge out there. There are so many other platforms that people are looking into. So it needs us to be better and faster and more accurate in what we are broadcasting.
Great, thank you. There are more questions, but I think we would like to pass on to Steinar, and we will get back with responses to those questions later. Thank you.
Yes, hello. My name is Steinar Søreide. I am joining in from Norway. We are based in the Media City Bergen building on the west coast of Norway, which is a really nice place to be for software companies. Our company is called Mjoll, and we have a product called Mimir, which is a software as a service platform that uses a lot of AI to extract and create metadata from media files. And this is something that we've been doing for a couple of years now. We do have a strong background in the media industry, about 20 years creating software for broadcasters and other media companies. And a couple of years ago, we had the opportunity to start from scratch with no legacy code and also with no customers in the beginning, which is every developer's dream. Everybody talked and still talk about AI, making use of AI in media production, which is becoming extremely useful. And also the cloud infrastructure is something that some of the media companies need help with. And we started this product as a pure serverless product running on the AWS infrastructure. So we are using Lambda and DynamoDB and Elasticsearch and all the managed services. And we launched the product on that platform in March 2019. and our first customer has been running since then. We now have about 20, and we have honestly had no downtime at all. We upgrade with a continuous integration pipeline on a running ship, so we can have users logged on and still be able to deploy new features and fixes while people are logged on to the system. So I'll give a lot of credit to AWS for that stability. What we are doing is to automate boring tasks, and we are using the traditional face detection, speech to text, translation, object detection, text analysis, type AI systems to enrich the media to make it searchable and easier to work with for the people that are working with the video production. The type of users that we are focusing on are the journalists and the video editors, and also others that are working with videos on a daily basis. So we have an end user product. It's not a consumer product. It's for professionals that deal with video. It's running, of course, in a web client, and also it has integrations to the tools that journalists and editors are using, like nonlinear editing systems and newsroom systems, to make it available, these AI technologies in their day-to-day tools. We have 4 main areas that we typically talk about, and the cloud infrastructure is a big one and probably not something we can dig deep into today, but we have the ability to tie into existing infrastructure so that customers that have cloud infrastructure that they own or on-premise infrastructure that they have, we can integrate with that, and we typically want only read access to the content, so we can read out the content from their buckets sitting in S3, and we generate our own derivatives from those files without us being necessarily responsible for storing them in our system. We just index them and make the videos that they already have available within their the different tools. But when it comes to workflow, it's the editorial search that I will focus on. I'll show you some examples of how we can use these data to find video. And then we have the integrations with nonlinear editing systems to make it easy for users to work with content, for instance, by using speech-to-text analysis and work text-based instead of always having to scrub through the entire video to find what you're looking for. We also have some features related to closed caption where we can do corrections of the transcribed content, and also we do translations and corrections on the translated transcripts. And we generate SRT files or text files so that it can easily be used in the video production tools. But enough PowerPoint, let's go straight over to a quick demo of Mimir. And I will go back to full screen and show a basic search on my web client here. I search for robot, and it will show me a list of clips that have matching, which are matching the word robot. The first one has a match in the title, and each line here represents one video clip. And the first one is because it has a robot detected. This is actually a label icon, meaning this actually came as a hit within the clip using AWS recognition, object detection or label detection. The next clip has several hits within the clip. So the first one here is orange. That indicates that it's a spoken word hit. So if I click on this, it will cue the video file to the time in the video where they are saying the matching word, which is of course robot.
Robot that can run.
And the next hit within the clip is again an object detection or label detection. And then there's a few other mentions of the word
robot is remote control.
Robot in this clip.
The robot takes care of.
I can also go into this clip to take a look at what we have extracted from it. So we see the transcript first, and I can of course just click on the word robot.
Robot is remote control.
And then we can see the timing of the words and the matching of the word robot and jump around to get a quick overview of what the content is. I can also look at the labels. So these are labels from AWS Rekognition. If I click on robot, it will show me all the detections of robots in this video. And I can also click on, let's do, I don't know, camera or door. So using these different labels, I can see where there are different detections in the video. Let's do another search. I will search for, let's do Boris and Brexit. So when I search just as free text, we try to be like Google. You just type what you want to have and then it will show you the most matching videos. And of course I get Boris Johnson. This one is blue. That indicates a face detection, which is coming from AWS Rekognition, the celebrity database. Of course he mentions the word Brexit.
Brexit that achieves
in this video. And I can look around here and look for what I'm, search for what I'm looking for. But right now I was just typing in this free text search. I can also do a bit more advanced search. If I know I want to have Boris Johnson in the video, I can go to my advanced menu and say, on the people side, I want to have Boris Johnson. And in the transcript, I want to hear the word Brexit. So when I do this specific search, then he is detected in all the different videos in my search result, and the word Brexit is mentioned in each of these videos. I can even do a same time search. So for instance, this video here has Boris Johnson and it has the word Brexit.
Brexit vote too.
But it's not necessarily Johnson that says the word Brexit. So if I enable this same time filter, it will only show me the videos that has Boris Johnson's face detected.
You can only do all those things.
And also the word Brexit.
Once you've got Brexit done and ended the uncertainty
within the same time frame. So you can use this to narrow down your search, and you can use all the different AI types of data together this way. So if I'm looking for, let's do Trump and Obama, then it will show me videos that have Trump and Obama in the same video at the same time. So it is videos where their faces occur together. I can do a similar thing with label detection. So let's go to labels and say, I want to have cars and helicopters. Then I will get those videos that have helicopters as well as cars in the video at matching times. And again, I can go into the video to see all the details. If I want to see all the cars or see all the helicopter detections, we can see that in the timeline here and scrub through it. When I search for content, we also support indexing the foreign language content. So if I search for coronavirus, which everybody hears too much about these days, I will get a lot of hits where people are talking about the coronavirus. But if I scroll down here a little bit further, I think I will also get some clips that are in foreign language. For instance, this one here. So here we see that they have highlighted the word coronavirus, but the language is actually in Arabic. So he's talking about coronavirus, and because we get a matching word in the translation, we get a match for this clip. And all of this metadata that we've been looking at so far is automated. So this is no manual human intervention to get these types of searches working. We can also search for similar words. If I search for Zelensky, that's how the president is writing his name. And I don't get many hits. I do get a hit in this translated text, but I can also enable a fuzzy search, which will give me more hits of words that are similarly spelled to Zelensky. So now I get the hits where they are saying Zelensky or writing it Zelensky.
Zelensky as part of the presidential delegation.
So you can use that to search for words that you don't know exactly how it's spelled and so on. Then I can also go over here to see persons. And when I look at these, this is coming from the celebrity database. So, and that one is a false positive. So I'm going to go back here and let me choose another one. Let's do this one. Which doesn't have any faces. How about this one? And here it looks a little bit better. So here we have faces from our private database. So customers can also register their own faces in the database. We can use the celebrity database, or we can have our private database. For instance, if I search for myself as a person or face detected, I will be in many of these videos. And of course, I'm not in the celebrity database from AWS. So customers can put in their own faces in our system, and we will find and match on that. We also do GPS coordinates, which allows us to do things like this. If I search for GoPro, I will find a video that has been taken with a GoPro camera with GPS. And if I go to the map over here, I can actually see the path that the car has been driving. And I can even click on the path, and it will jump to the corresponding time of the video that matches that GPS coordinate that I'm clicking on. And this is extremely useful when you have metadata in the cameras, and we can use this in combination with AI-based metadata. So if I go to my map search view, I will see my entire video database presented on a map. And then I can say, for instance, not GoPro, but I want to have video clips that have snow in them. And it will then show me a bunch of hits in Norway where we have a lot of snow, and I can click on them on the map, and it will show up the video clips in my player here. And I can combine that with my time filter and say, show me what's both snow tagged in that date range on and also within this map view, and it shows me the clips that have all these matching filters. So journalists can use this to narrow down the search. And when it comes to GPS data, typically you would need to have that as in your camera with a GPS receiver. But we've also done some interesting work which involves AI when it comes to the subsea section. So if I search for ROV, I will find a clip here that has map information. So I will find it, but it's actually out to sea where Google Maps is really useless. And because of that, we also have this feature that can enable data overlays where we can show the pipelines out at the North Sea, and then show the different ROV videos placed on that map. And this is actually extracted from the video using these easting and northing data, which is burnt in as text. And then we've been using AI to analyze the data and converting that to GPS data so that we can present it on the map, which allows the oil and gas industry to place videos and search on the map. Combining that with the time filter, they can see where they have been on different years of inspections and so on, based on automatic metadata. So I think maybe that's as much as I have time to show for search. I'll do a quick preview of how things work for video editors. So I'm jumping over to Adobe Premiere Pro, where we have our panel, which is basically the whole Mimir product as an extension panel inside Adobe Premiere Pro. This allows video editors to access their entire archive, which can sit in cloud infrastructure or on-premise, and they can basically import content by just a click of a button, and it will then be imported in here. This one I have not used before, so it will be downloaded, and right now it's downloading the proxy version of the video file, which might be just a 1 or 2% size compared to the original material. But we have a feature that we have implemented together with Adobe, where we can work in proxy quality. So now I can work with these files. I can bring in a sequence here. I can also bring in the subtitles that was generated based on the speech to text, and maybe even go to the translation, which is in English now, even though she is speaking Danish, I believe. And yes, so the transcript is in Danish, the translation is in English, and I can import this subtitle by just a click of a button, and then I will get the subtitles in here as a caption file and bring that in here, and then I get subtitles in English, which is all machine generated, and then possibly, of course, corrected using the Mimir web frontend, or you can do it directly within here. I'm actually logged into Michael Jensen's system now in Denmark. So right now, if I go back to my little presentation thing here, I just want to show a small diagram of, of where the media sits and what is stored in cloud and what is stored here. So I was able to log on to his system or his account, which is stored in the AWS infrastructure. The media is stored on Glacier if it's old, it's stored on S3 if it's new, or if it's daily source material, it's only stored on premise. And I don't need to think about that as a user. I just logged on to my account and I can search in the entire archive. And then when I finish my edit, I'm only using the low resolution version of these files. And if I then go back and create a sequence out of this, I can export this back to my account using our Mimir panel. And then when I export my edited sequence that I have created, I can enable this central render. So I'm doing now a demo clip. I say upload sequence, and the only information that is transported back is the actual timeline, the project or sequence from Premiere. This is now being picked up by Michael's infrastructure in Denmark. So now there is a Mimir component that runs on his close to his storage that will pick up the project file that I generated here and render it close to where his media sits, or if some of the media sits in his Glacier storage, our component will download it or restore it, and when the restoration is finished, it will render the file and put it back into the production system so that he has a quick way of getting this on air. So this enables the users and the journalists and the video editors at his place to use AI and get access to this in their day-to-day workflow tools, but being able to work from any location, from home or sit on premise, and without thinking about all the file management parts of this. So I think that's it. I think that's what I had time to talk about today. So I'm open for questions. Thank you.
Great. Thank you, Steinar. Very interesting. Let me check. We have a few questions. Let me see. Maybe we start with this one. So the question is, can you use the corrections done in, for instance, a transcript to train AI models?
Right, yes. Of course, with many users doing all these corrections, then we can store the corrections and we can store them in our database. It's not all the different AI services that support training or corrections, but we can store it. And by having that data separate, we can then train the data model when needed. So it is possible.
Okay, great. And maybe we can just take one more question here is, what is the business model for Mimir?
Yes, Mimir is a software as a service, so it is a per user per month license to get access to the system. And then for the different AI services, it's basically pay per use. And we use the different AI services and we meter how much each customer is using. And then that becomes just part of the monthly bill to our customers. And of course, we're just using the list prices like Rekognition and the other services that you have. It's a one-to-one cost.
Okay, great. I think in the interest of time, unfortunately, we have to wrap up here, but there are more questions that we will definitely get back with responses to, together with Steiner and Michael and Neil. So yeah, thank you very much.
My pleasure.